Geological Society of India, is it you or is it Krishnamurti sir who has joined?
Sir, I joined from this account, and I am also using my personal account for.
This Geological Society is yours. Which one? Yeah.
Yes, sir.
Okay, fine. Well, maybe we can start and others can join as they.
Yes,
We
I
are
feel
having
so.
around 38 participants have joined. I think we should. I think we should go ahead.
Yeah, 42 it shows. Yes.
Yeah. We have sufficient number. I think.
Yeah. Yes, we must
Please
start.
go ahead. Yeah. And Devinderji, please record this so that we can share for other people. Devinder?
It is recording already.
Okay, sir. Shima, you can give formal welcome to sir.
Yes. A very good evening to all of you present in this webinar. We are pleased to start with the first lecture of this year 2026 being held by the Geological Society of India Delhi chapter. Our guest for today is Professor Naresh Chandra Pant ji, and he is not in dearth of any introduction. Still, as many of you are probably new to him, I would like to give a formal introduction to him. Professor Chandra Pant is an eminent geoscientist with over 4 decades of distinguished service in academia research and national scientific institutions, having retired as senior professor from the University of Delhi. He currently serves as visiting honorary scientist at the National Center for Polar and Ocean Research, Goa, and is also a member of its Research Advisory Committee with long-standing involvement in the Indian Antarctic Program. His scholarly contributions span metamorphic petrology, mineralogy, crystallography, polar science, and advanced analytical techniques with pioneering work on Archean high-pressure metamorphism, supercontinent reconstruction, and innovative EPMA applications. Professor Pant has carried out extensive geological investigations across the Indian Shield, the Himalaya, Northeast India, and Antarctica, resulting in over 120 research publications 6 edited book volumes, and supervision of many doctoral research scholars. It is our great privilege to warmly welcome Sir to this webinar, and I respectfully invite him to begin his lecture.
Thank you, Ashima, and thank you, Geological Society of India, Regional Center, Delhi. It is actually my privilege. So I'm going to take a little bit of time for during this. But if you get bored, we can stop in between any time, sure. So what I'll do is that because to save time, I will begin with sharing my presentation first, and then we can interact. I can be interrupted anytime in between, please. So I'll share my screen. So are you able to see the screen?
Yes, sir. Please go ahead. Yes.
Okay. Yes. So a lot of old friends, a lot of senior colleagues also. Rasik Saab is there, is an Antarctican and former director of NCPOR also. It is actually not a very interesting topic, but I hope that we have an interesting interaction. But the title actually speaks of the country's ambition in some sense, which I hope will become clearer as we proceed. So the way I would like this discussion to proceed, I hope it is discussion, is that a question of why at all it is relevant or it should be there. What we are proposing as a title, that is the geological exploration of Amery ice shelf in Princess Elizabeth Land region of Antarctica. I'll introduce you to this. The question is of then if it is justified as to the reason of taking up the work, taking up the challenge, then how we go about it. Again, I'll explain why how is so relevant. Thereafter, we look at the terrain in which this investigation, this work is going on, that is Princess Elizabeth Land or PEL in short, and then we will discuss some of the results. However, before we start with this, I would like you to look at the map of the world as it was seen in the year 1565. You see that if you look at the southern part of it, you don't see any evidence of presence of what at that time was considered, whether the presence of Antarctica was known or not. So it was the map which was in fashion at that period of time. We go further or in younger history and year 1770, look at the Southern Ocean and south of that part, there is no Antarctica. So it is actually a continent which was unknown till very, very recently. Remember that in 1609, Galileo Galilei had already used the first time described Mars, which was very, very far away, a visible planet. So Mars was known, but I'm not discussing the adventure of the location of Antarctica. We actually come much, much later in 1942 to a situation where there were claims and counterclaims on Antarctica by several countries, Great Britain, Chile, Argentina, Norway, France, Australia, etc. Not the US and the USSR in this list. There were overlapping claims also. This is also not what we are interested. It's just to tell you that it was a very recent discovery of a terrain, relatively very, very recent discovery of the terrain. Once it was discovered, once it was realized that there is something, an icy continent of more than 14 million square kilometer. Of course, the area came late. The investigation turned on to, and again, that history is not relevant today, into considering and saving this as an isolated, it was very isolated, saving it as it is. And the reason even at that time, in the beginning of that science, beginning of that time, was realized that the remaining of Antarctica as it is critical, crucial for us. However, in recent times, in light of global warming, and despite what has happened today or yesterday, in terms of a country withdrawing from most of the international agreements or treaties in the scientific context, Antarctica has created an awareness about what it can cause, the issues or the problems which it can cause at far off places. We are more than 10,000 kilometers away from Antarctica. And often, and I have faced this question, that why at all we are actually interested in investigating and learning. You'll see that how it is important for us. So there has been a lot of science a lot of activity during last more than 50 years, which has allowed us to understand it to some extent. All that understanding in today's climate change context gets translated into the sea level change, which is only one of the consequences. The sea level change estimates are good, but with different scenarios of what we say that global warming, the uncertainties in these sea level changes are of the order of 100% or around 100%. It is not only that the likely melting of the Antarctic ice because of rise in temperature or global warming, which is projected as a major threat to human society. It is the consequent changes in precipitation, in droughts, in floods, in affecting the biota, in affecting the let us say the agricultural production, the fisheries, which impact us. And these are very well documented in IPCC reports, the last one being AR6. But one thing on which this talk is focused is that we don't realize, or we have started realizing, that Antarctica is not only melting from top, it is melting from underneath. And when you look at this picture, the thickness of the ice here is average 2 kilometer, at places more than 4 kilometer also. So the surface global warming is unlikely to affect what is happening below. So this melting from below is what is the focus today, and the context of that I will explain. Well, when we look at this terrain, and just to give you an idea, I have put or combined here the map of Antarctica, map of Europe in the first panel, map of continental United States in the second panel, and area of India and China in the third column. Antarctica, as you can see, is bigger than. Antarctica is more than 14 million square kilometer. And if you see the area of India and China put together, still there is a change of more than 1 million square kilometer left. So it is actually a huge area. We look at the map, the huge area with a very great thickness of ice. It has many consequences. So this is something with which we are dealing. When we look at, I am approaching 70, and if I was to, if this was the half of my age, another 70 years or close to that will create a situation where there will be, as we project today, with a lot of uncertainties, a 1 meter sea level rise. A 1 meter sea level rise, I'm only quoting one instance. In a city like Bombay, it will lead to 20% of the city's land being lost. The kind of consequences which can happen to a place which is so far off from Antarctica is, we are not in talking about this in greater detail, but it is just one example which is sufficient to tell us. So the question is, many of us are geologists. The question is, why in this context the title, the subice geology part, why it is important? We will try to learn this in little bit of a greater detail, because it is something which is not being discussed well enough globally also. So when we are looking at the ice which is melting from below, in last about 3 decades, there have been a lot of investigation. These investigations are through the aero-driven radar, the aerogeophysical signatures, which are able to penetrate beneath the ice and find out the water bodies below. These water bodies are of various kinds. If you look at the first picture, they are like big lakes. And this, on this picture, you see around 700 such spots where these large bodies have been found. So they occur as lakes, as almost rivers, canyons, in many, many forms. And they are deep inside, and they are deep beneath the ice. Possibly they contain some of the oldest water which is present on the surface of Earth. One of the factors which we believe is important in producing this water or melting this ice is the subice geology. And its understanding, that is the understanding of the subice geology, is absolutely very, very minimal, for the reason which we will see very, very, very quickly. So when we are looking at this ice, the surface melting part is 1. These days, there is a factor or a term which has come in Antarctic context, that is vulnerability. The vulnerability essentially refers to, in the climate change context or in context of whether the ice will remain in Antarctica or it will partially melt. As I told you, the surface melting is only one aspect of it, which is related to global warming. But there is that deep beneath melting, which is where we believe that geothermal heat flow or geothermal heat flux, because Earth is reducing or leaving the heat, and that heat is possible that it can melt. And that control is something which we do not understand actually. So this becomes an important factor which we try to understand. Now, just a little bit of detail in trying to understand how this heat from beneath comes. There are 2 two major sources. One is the mantle heat, which is coming from below, cooling Earth, and then there is crustal radiogenic heat. Dominantly, these are the two sources. Now, when we look at the mantle heat, it is generally considered that it is broadly uniform, that is 12 to 8 milliwatt per meter square. But we know that there are volcanoes in Iceland. We know that there is in Hawaii. So the mantle is almost at the surface. The mantle heat is much more. But we can also think of intermediate situation where there is crustal thinning and the mantle is uplifted, like in rifts. There also, this broadly uniform rate of heat from mantle will not hold good. So therefore, it is highly variable. So this particular component, that is the mantle heat, is variable and is dependent upon the distance which the mantle has from surface. Similarly, the radiogenic heat is also non-uniform. So there could be a orogenic belt or a fold belt. Aravallis, for example, are in discussion these days. But a fold belt like Aravallis, where there is a lot of granites which have been produced, so they are high heat producing elements, and those will have a much higher effect compared to the areas which are adjacent to them or the low-lying areas. So therefore, there is a heterogeneity which is structurally controlled as well as lithologically controlled. And this we can only know by subice geology. How do we work out the subice geology of Antarctic ice sheet? Look at this, kilometers thick, as I said. And if I look at the same example which I took from Galileo's exploration in 1609 of Mars, today also Mars is much nearer to us in that sense. This is an examination of Mars, which is published paper by Yin et al. You see that the rift systems, the slips, structural elements are amenable to analysis from a great distance, 250 million kilometers away. And in Antarctica, even when we go there, we are not able to work that out. So therefore, the problem, it is actually a great challenge to work out. And as I said, it is essential as a boundary condition, as a possible boundary condition for the stability of Antarctic ice sheet, especially East Antarctic ice sheet. So when we try to look at the Antarctica, which we are seeing, and we have indirect evidence or looking at various geophysical signatures, we see that there is tremendous heterogeneity reflected in the geophysical context also. There is thinner crust in the West Antarctica, thicker crust. Then there are the East Antarctica, you see the blue colors or different shades, they possibly represent a different assembly of continents, different assembly of past assembly. But we need to decipher this and understand. This is a gravity data-driven map, but we need to decipher that. Remember, this is 14 million square kilometer years. To work out the boundary conditions which we are looking for, it requires a much, much better resolution and data. So one of the ways in which we can do this is by looking at this. This is here is Antarctica, and we look at the past adjacent terrains of Antarctica and contiguous geology. For the coastal regions, we try to work that out. For example, this is African affinity terrain, Indian affinity terrain, and Australian affinity terrains, like this. However, for the large area of Antarctica, it also only provides us as a very, very insignificant information. So we try actually to combine this, and some examples I'm showing you from the work when we were in Geological Survey of India and working in the terrain, which is called as around our Maitri station in the droning moorland area. So we using this continuation with Africa, the extension of East African origin, we brought out around up to 200 kilometer inward of the coastal area. However, these are few sporadic studies, and they do not lead to the kind of details which we require for understanding the subice geology. The next question then is that how actually we can do or we can refine the ideas which we have from the adjacent terrains, the ideas which we have from other sources, that is indirect sources. So there are three ways of looking at this. In the coastal tracts, there are some outcrops. 2% of the Antarctic terrain provides the exposures of rocks. So we can do measurement there, we can analyze the samples from there, we can collect the samples. So that is direct measurement. The otherwise, what we can do is we can use geophysical and remote sensing techniques to generate data which can give us clues about what is beneath the ice, and these are called as indirect. These I call as indirect evidence. Then there is a direct indirect category wherein we have the material which has come from Antarctica, but it is not at that place. So it is either transported to the adjacent coast marginal areas as marine sediments or as glacial sediments. So these are the three ways in which we can combine the knowledge and work out and refine the subice geology. So when we look at the direct method exposures, and I will give you some results. So they are because the exposures are very clear, relatively way to accomplish very good studies on that. This is from the very close to the Bharati station of India in East Antarctica. And then indirect, we have remote sensing and geophysical signatures. And that also we have collaborated in a project which is known as IceCap again in Princess Elizabeth Land area, where it allowed us to, you see, this was the state of the subglacial topography at that point of time, which became much better refined after this project was done. I will talk about the results. It is just the method in which we are using. And the geophysical data, which allows us to guess or estimate using the magnetic and other anomalies to think about that the terrain boundaries, the orogenic belts, the rifts, etc. When we look at the direct, indirect methods or data, that comes from the ice-rafted debris, the iceberg carrying the material from the land and depositing it. And then if you are able to get the sediments through drilling, those sediments can give us clues about the geology of the land area from where they have come. So these are coast marginal sediments which help us in that. Then also there are ways in which we look at the talus, the moraines, etc., the glacial sediments, which allow us to link them to from where they have come. For linking them, we look at the glacial drainages, which have brought the material from deeper interior, several hundred kilometers interior. And if we are able to analyze and link, and then we can conjecture about in a much better way about the subglacial geology. So you see, it's very interesting to see that where the drainages reach closer, you have the sediments, that is glacial sediments. Where the drainages do not reach, you have relatively cleaner, sediment-free kind of areas. So the drainage carrying capacity, drainage course is very interestingly relatable to the nature of sediments. So the marine sediments are there, of course, which we use offshore sediment samples, and they are available. We will talk about that, not from direct drilling, but from the earlier drilled wells. We can use them. But the glacial sediments can be in various forms. They can be end-glacial sediments. They can be on top big boulders and erratics. They can be in various forms. It is, of course, tough to sample and use them, but they allow us a peep into from where they could have come. So with these methods, let us look at for a few minutes on why we are concentrating or talking about Amery ice shelf area. So when we look at this, it represents a very interesting area. It represents world's sort of largest glacier, Lambert-Emery Glacier. Lambert Glacier is a very large glacier. It also represents 16% of East Antarctic ice sheet area. So it's actually a very, very representative. If you are able to work out a good sub-ice geological map and relate it to ice mass wasting, it will be a great contribution. You see, in the Lambert region, in that area, the ice velocity goes up to 1000 meter per year, a kilometer per year. And in the adjacent areas, slightly away from that glacier, it could be as low as 0, practically not moving. So that sort of ice mass wasting, and this ice is going into the ocean. Then at few places in this area, very high geothermal heat flow has been observed. By very high, I mean 120 milliwatt per meter square. This has been also, there have been 1 or 2 measurement of Curie depth in the Lambert region, which corresponds with the high GHF, in the sense that the Curie depth is very low here. So therefore, it tells us that it is elevated temperature. And lastly, that it is, by conjecture, it is an area of geological complexity. Not by conjecture only, but by available information of the exposed rocks. So therefore, it is a very suitable area for doing a project on subice geology, aiming towards building a boundary condition which is able to give us an idea about how the ice mass wastage is influenced by subice geology. Besides this, of course, the important thing is that India's Bharti station, the latest station, is there, and it is logistically possible. In Antarctica, doing anything which is logistically not possible is very difficult. So it is logistically possible to implement some of these activities. So when we look at the things which I was trying to tell you, that this light green area is unresolved. We don't know anything about geology. These areas are some where we have a reasonable idea, and we have terrains which are very old. So these dotted ones, light brown ones, are the very old Archean terrains, and these are relatively younger, but Proterozoic to Neo-Proterozoic areas, and the rest is something which we don't know. There is also a word written here as GSM, which refers to gambuts of subglacial mountain, which is basically a kilometer or more than a kilometer actually much more than a kilometer high mountain, which is below the ice. And it is actually a mystery. It is actually a very high relief in Antarctica, below the ice, of course, not seen, and it needs to be explained or understood. So when we look at these factors, get all the data which is available, look at the terrain associations, and look at the geophysical data, which gives us, this is the PL area, which gives us an idea of lithosphere asthenosphere boundary depths, which shows high variability in this area. You see, this is much higher, and as we proceed inward inside the continent, it is much lower. So there the heterogeneities are very nicely. It explains us or it gives us a very good theater to work this out. So when we look at, again, Lambert Rift, I'm expounding a little bit more. This is the glacier. This is the Lambert Rift. I'll tell you, we have done some work on this. So what it is telling us that there are some data available which tells us, though this may be a Gondwana breakup time rift, but it has been activated over time. So we have evidence of activity over a period of time which starts from around 300 million years to 40 million years. So therefore, it is an area which has been intermittently active in terms of supply of magmatic material. Actually, as we go in this area further up north, let us say here, there is evidence of recent volcanism also. So there is an area which is the analogous area to this is Mahanadi Rift here. In Mahanadi Rift, there has been some measurement of geothermal heat flow, which reach up to 107 milliwatt per meter square. So there is an adjacent terrain which also tells us a similar kind of behavior. So it's a very good area. So for this, we selected a 400 kilometers radius circle. The reason is that the maximum reach of the logistic reach of the helicopters are of that range, even with the when we drop fuel dumps in between. So it is this sort of area which is what we went out. Our objectives in this have been to work out the multiple orogenies if they are there, or to resolve these suture boundaries, etc., to work out the structural fabric wherever we could, and then relate it to the adjacent terrain, and to talk about the Gambutsov mountain link, or what it actually means inside and what it actually means for the geothermal heat flow and cryosphere there. So now I will quickly demonstrate some of the results which we were able to work out. This is an activity in progress. About 5 years have passed, and there have been about publications in double digits, but some of the interesting results have started coming in. So I'll just brief you about that. So we use with the direct method exposures, in which we will look at two terrains. The work is dominantly in the vicinity or in that area which I showed by that circle, the vicinity of the Bharati station. So when we look at this, I will not give you very big details of this area, but will show you some very new and interesting ideas. This area which we are talking about is about 70 to 100 kilometer along coast. So these are some exposures using the direct method which we have been able to sample. They were studied earlier also. However, what our results or what our work has been able to do. It involved field work, it involved fabric measurements, it involved very detailed petrography, it involved dating of rocks, it involved the modeling of the reaction using the equilibrium thermodynamics approach. So it was a combination of multiple factors. As I'm not detailing those, other than looking at the results. So what it actually brought about is that in this 70-kilometer coastal fringe area, we were able to work out that there was a decompression, there was an uplift, tectonic uplift of 15 kilometer, which represented a 5 kilobar decompression. So 15 kilometer tectonic uplift. And we constrained this with time also. That not only that, we also were able to work out that there was an ultra high temperatures, metamorphic temperatures reaching more than 850 degrees centigrade. Now, this was constrained with using multiple geochronology techniques, including in situ monazite dating as well as zircon dating. Now, what that allowed us to do is to work out something which was known first. What was known was that there is a 500 million year old or a Pan-African orogenic belt. But what our work brought out additionally, that there is also another event which is possibly of similar nature, which is of 800 million years. Remember, this area is adjacent to our Eastern Ghats. So whatever we are working out here has to find a reflection in the Indian context. So this allowed us to look at a 700 to 800 million year event, which was generally not reported from Eastern Ghats earlier, and from Antarctica also, and a reported 500 million year. So what we corroborated this with zircon, some of the zircon isotopic data also. So this is something which allowed us to refine this. We also discussed or brought out in context with the subsurface magnetic anomalies. So there were two fabrics in the magnetic anomalies which matched with the actual ground fabrics which we were seeing on the outcrops. And this allowed us to look at the correlation in a totally different way. Why? One, that we worked out a 500 million orogeny which cuts across the coastal area and passes into the northern part of the Eastern Ghat province. The northern part of the Eastern Ghat province. We'll talk about that also. And also, when we started looking at the Eastern Ghat data, we found that there is a lot of 800 million year old events and data which are being reported from the northern and the central part of the Eastern Ghat mobile belt. So there was something which was which actually started a kind of new trend in the Eastern Ghat mobile belt also. So this is something which I'll show you in a bigger sense that how it got corroborated by other things also. There was some work by a Chinese team which looked at the geophysical data over a traverse, and that traverse coincided with what we had discussed as the range of the 500 MA or the trend of the 500 MA orogeny, and therefore it got corroborated by independent geophysical data also. And this arm of the 500 MA event, there is known as Kunga suture in that area. So that was geologically and geophysically correlated. We also looked at the sutures of some of the terrains in that area, which were debated, but with our IIT Kharagpur participation in this GeoEAIS program that also got corroborated very nicely with the Rangali province area in this. Finally, as I said, that there was an important contribution which has been published only very recently, this year only. At the end of this year, it will be in print in 2026 only. That what it allowed us to see that the Eastern Ghat province of India is actually a part of the Rainer, or it evolved with Rainer complex of Antarctica in this segment. And therefore, the EGP is actually not a part of Cratonic India. It is actually a part of Antarctica, which is residing there. So this was one major conclusion, which has come out only recently. In a domain which is east of this area, which is called as West Hills, and it is an Archean terrain or an old terrain. There also we were able to demonstrate an ultra high temperature metamorphism, and we were able to work out that it got reset at a younger age. So these were the few interesting points from these two terrains which we were able to do. In another related working out of suture, which involved in reinterpreting the gravity data and the geological data, we were able to mark a suture beneath a glacial ice. So these are some of the highlights of what we were able to accomplish in this terrain, in this area, which were new things. Then in an area adjacent to Lambert Graben, towards east of Lambert Graben, there was work which was done by Ice Cap team, and they reported a system of canyon, and prior to that also, which was around 1100 kilometer long. It's like a very large river system, part of which is filled with water. Remember, all this is beneath thick ice cover. So we investigated how can this system develop, this system on the surface of the bedrock develop. For that, what we did was that we did analog modeling of generation of Lambert rift, combine that with the existing fabric on the surface which was there, and predicted how this system of canyon could form. This was Dev Samriddhi's PhD, part of the PhD work, and it is actually published in 2020 in Gondwana Research, and it is actually very well accepted. So this is the way this was modeled, analog modeled, and actual structural experiment carried out to work this out. Then now we look at few quick results from the marginal sediments, and I'll just explain to you how we arrived at this sort of data. So when you look at this red boundary, this is the boundary of the major glacial basin. In this, if you see in the deep drilling sites, 740, 742, 739. Now these deep drilling site, the projected flow lines or supply lines of the sediments represents two domains. One, where the Lambert Glacier is largely feeding to 742 and 739, and where the other one, where it is possibly not influencing. And this was actually worked out with using the marginal currents, etc. So this is how we arrived at. And then from these sediment cores of a particular age, we analyzed the rock fragments, etc. Now this area, as I explained to you, is a high grade metamorphic rock area. In that we got some low grade material. Now that low-grade material, schist basically, or schist and slates or low-grade schist, can only come from interior because this is the boundary which marks from where the sediments can be sourced. So that associated with those rock fragments in the sediments, we were able to date the same 700 to 800 MA event which we had detected in the earlier work. And these were also corroborated with the zircon data which was recovered from these sediments. Now, when we looked at the zircon data, it actually corroborated the presence of many of these terrains, but it told us about a 700 to 800 million year event terrain, which was of low grade, for which none of these areas provided corresponding geology. So therefore, it appears that because the sourcing is from the Gambutsa subglacial mountain in this area, so it suggested that possibly low-grade terrain may be of age of 700 to 800 million years or younger. Similarly, looking at the detritus or the moraine material in the high-grade terrain of the Westfold Hills, we found slates. So this also is being worked as to from where this could have come and how it can allow us to interpret the hinterland subice geology. So what we are trying to do now is that using all this data and adjacent terrains, and these adjacent terrains now with stars and numbers represent the geothermal heat flow readings. So we are trying to model these in conjunction to provide the similar kind of heat flow data for Antarctica. And once we have that data and the refined subice geology, it will give us a much better control in understanding the ice mass vestiges, in understanding and in also predicting the future behavior. And also in if there are things to be done, like major geoengineering things, it will also help in understanding or designing that. This work required not only what we are saying in terms of technical input and work, but also establishing very difficult terrain, some outposts. This is one camp, quite far from the station, which is where we can go and live for a few days, do some field work. So this kind of thing, setting up fuel dumps, etc. This camp is 227 kilometers from Bharati, from a helicopter, under very hostile conditions. So we are trying to do this, extend this up to the end. So let us see how much it is possible. These fuel dumps are established, whether this can be taken further. So if I summarize, that we have been able to provide some new data, we have been able to unravel a new orogenic event, we have been able to say that the Eastern Ghat province is actually a segment of Antarctica which is stuck with India at the moment. And if we can talk about the first evidence of what is there in Gambutsa subglacial mountains, actually looking at the material. So these are some of the things which we have been able to. However, there are still many more things to do. Those things require basically, these are the teams of different people. I have not been there, let me tell you, in this. There have been people from IIT, Chandra Chatterjee, who did his PhD, Dev Samidhi, who did her PhD, Mayuri, who did her PhD, several Geological Survey of India teams who have contributed to this. And you see coal here at Beaver Lake coal beds. And a student from BHU, Dr. Rashmi Gupta, looking at the marginal cells. So all this summarized in a short talk is actually coming from all of them. So we have been able to provide some of these things. We have been able to come up with this thing. What is missing right now is a big geophysical input, for which already looking at or working with the IIT Roorkee and NCPOR team, we are trying to do a field or trying to develop a field which is basically technology development also on cryoseismology, which is going to help us looking at the cryosphere also and looking at the subsurface geology. So this is something which we have been able to accomplish over a period of several years. The participation in GeoEAIS is open. If you have ideas, if you desire to be part of the program, the invitation for program submission actually I think was out in today's newspaper only. Every year it is there. The program is evaluated in a workshop. Anyone can submit, and we can take it further. And of course, this is all part of NCPOR. I'm also in that sense part of NCPOR. I'm mentoring this basically. Thank you for your attention.
Thank you, sir, for your interesting talk. I would now like to invite questions from the audience.
Shall I unshare this first so that we are able to look at? I was not able to look at any.
Yes. The talk has been so lucid and so nice. I don't think there will be any questions. It was really an insight into the entire geological history of the Eastern Antarctica. So really thank Pansa for that. Thank you.
Yeah, my thanks also to sir for so much effort and explaining so nicely.
Thank you. Yeah, but this sometimes mean that I was not through. I'll be very happy to have some criticism also and some questions also from young people.
All
So
the
easy
research
student.
scholars present
Yes, we have some GSI people
and
also.
students.
I think it's their dinner time.
Now, Bhaskar Sahab, you must appreciate that even
Yes.
now also there are about 90 participants. I
No,
don't
no,
think
it is a great number.
yeah,
In
it's
the
a great
webinar,
number.
it is a great number.
Yeah, I have never seen a number at
Yes,
that large
yes,
extent.
sure.
Yeah, it
Surely.
speaks of Pansab's great, popularity.
Yes. Yes.
Yeah.
Sir, if nobody has a question, I can ask. I want to ask you a very generalized question. Do you see this sub ice melting? Because we have these episodes of continental amalgamation and disintegration, which has been going on for quite some time. And we do not exactly know how this actually disintegration is taking place and how this is amalgamating, even though there are many theories regarding this, or many propositions are there. Do you see this sub-ice glacial melting and reclaiming of this landmass and inundating of the other water sources, probably as a way of, the plates rearranging themselves in the bigger picture of supercontinent cyclicity?
I'm not sure that the glacial isostasy playing a role in creating a fracture and creating unloading in a sense that it creates a fracture to initiate a plate motion. Because as you know, bulk of the plate motion is through that thermal convection, which is from deep within. Maybe there may be a hotspot activity which initiates that. So probably the bigger driver is that. However, there is something very interesting, and I said this in August in Chile also, that what I see that the significance of the water which is below, the significance of the subglacial water which is present, if it is not controlled by uh, the surface heat, and if it is kilometers below, isolated, you could have some of the oldest water, maybe even in terms of millions of years old water, which may be there, because there is no escape. It's a huge continent, and you have in the center, you have these water bodies. So this is what I said, that this is something which is a challenge. And there were some very interesting observations also. So there are some deep drilling which are being done or being planned. There are a lot of work going on for that, where this is one way it will be checked. But second thing is what I wanted to say. I thought you will ask, because of you being a mental petrologist, that is it possible that some kind of situation, this water, when the breakage occurs, when a breakage occurs and you have an uh, isolated water, can this seep into mental processes? I mean, you understand what I'm trying to say? Is there a possibility of isolated water bodies being the source of water which is predicted to be present in the in mental areas or mental layers? So where the plate break up and they allow the seepage. So in that sense, yes, this thing.
Uh, as for this mantle water, usually what has been so far found out is that they are hold in the mineral structures. So obviously, if you have deep fractures and you are initiating, obviously it will catalyze certain reactions. That's for there, because we all know that olivine serpentinization is one such hydrolysis, which is one of the reasons why these are being very seriously followed up, because serpentine phase transitions are now believed to be the reason for this major reason for subduction related dynamics, that it is one of the major phases which actually catalyze the process of subduction to deeper zones, not the shallower subductions but the deeper subductions, because some of the slab remains are found in the D double prime layer, which is the um,
Very, very
layer
deep.
between the mantle and the crust. So
Yes.
those deeper subduction plates are believed to have been like buffered or being catalyzed to down deeper part because of the this structure of the serpentine group of minerals. So there has been studies on those lines, and seismologists are working on those things. But yeah, well, sir, obviously addition of water is definitely going to have a say on all the reactions which might take place.
So that
That's
is
there.
a petrologic or that context. But what is becoming evident, there is Dr. Waliur Rahman is there in NCPOR.
Yeah.
He had recently he's giving few talks, and he has published some work which is saying that even 1.5 degree, that is the Paris 2015 agreement target, will not lead to the saving of the ice, saving of the polar ice, in the sense that it is the situation is much more grave. Of course, right now with the conditions, political conditions which are there, everything is in danger. But what we have, I genuinely meant that if I was to live another 70 years, it's probably going to be a very, very problematic world extremely problematic word, and we do not know. Our uncertainties of science are great. If you will permit, I will just say one more word actually. That
Yes,
is,
sir.
question has been asked sometimes from me is to, when this level of science is so good in Antarctica, why there are so big uncertainties in such predictions? Then I say that, and that is why I keep on reminding that the area of Antarctica is very large. At one point of time, maximum number of people in Antarctica are around 5,000 in summers, in Antarctic or austral summer. So therefore, the amount of data and amount of science which comes is insufficient. Now, if there is a lot of investment in terms of effort is needed, money and effort. If we are withdrawing some of these, if we are becoming less, our uncertainties for the future generations are going to become much, much bigger. So that is something which is very important for us. Whether we are very far from polar regions. This is something which has to be very clear to for younger people. I mean, it's more and more trouble for younger people.
Yes, a question, Ashima, you can ask, read it out. In the chat box, I saw somebody writing something.
Ma'am, unmute yourself first. Ask me, ma'am.
Yeah, can the student write directly ask, because I'm unable to see the
There
chat.
is nothing. No, I have seen the chat. There is nothing in the chat box.
I think
What is-
Lisa has written a question. Lisa, can you ask the question?
Yes, ma'am. Am I audible?
Yeah.
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 Good evening, sir. I have a very general question that we all talk about the melting of ice nowadays and about the global warming occurring. So, whether we are worried about the melting of ice because it is happening in the human life scale, because as per the cycle of glacial and interglacial periods, we are in the interglacial period and moving towards the glacial period after the Pleistocene ice age. So, we should be worrying about the glaciation incoming instead of that greenhouse.
Okay. The scale at which the glacial interglacial cycle move uh, is too slow for human life in context of human life, and that takes longer time. It's not that from tomorrow the glacial cycle will start. So the transition is over a longer period of time. So human life cycles are much smaller than that. First thing is that. The second thing is that and ice is not behaving uniformly all over the world. Actually, Antarctic ice is melting on surface, but ice mass balance is highly variable. For example, Arctic is warming as far as is 4 times higher than the average. In Antarctic, the East Antarctic ice sheet is considered to be relatively stable. It is not melting much, whereas the West Antarctic ice sheet is melting very fast. There are many reasons for that. The main reason being that West Antarctic ice sheet, or that part is largely marine based, or the sea is very close. So there is a highly variable way in which ice melting is taking place. This Antarctic ice sheet, till late, people were saying that it is not showing a negative mass balance. That is, it is either neutral or slightly increasing in mass, which has also been contested. So this is what I'm saying, that the data which we have, despite some of the best people working, the errors are still high enough for us not to be very conclusive about things. And all of you young people have to look at this in a context where you are able to provide, where you are able to look at this and provide less errors. The GeoEAIS program is one small effort from India in that direction, to look at the boundary condition, to define the boundary conditions, to reduce the errors, and to have better control. Lisa, I'm not sure. Did you get some?
Yes, sir, got it.
Okay, good.
Sir, are there also other reasons to watch out for, like for subglacial melting apart from the Antarctica?
No, not really. But
What are
why?
about the other permafrost reasons, for instance, in the Russian Federation and all those areas?
Yes. So there are, well, since you are not looking for Denmark, people are looking for Denmark for thinking that the ice will go away. So what happens is that in permafrost domains, basically there are many kinds of factors. One of the factor is detrimental to environment in terms of release of higher methane and more carbon dioxide, or so that is what is causing the problem in Arctic context. Rasi Saab is there. He can answer about Arctic. He's an expert on Arctic, so he can talk about that. But Arctic, this issue is taking place. So there are positive and negative impact of the things. For example, in few years, the summer ice will not be there, so the sea route trades will be open. So that will change many things. I mean, that will shorten some of the routes, and it'll become better for in some sense. But overall effect of these things are negative. The IPCC, this is thousands of scientists to get together, the IPCC results. When you look at that in totality, in terms of the illnesses, in terms of the food insecurity or security, in terms of the sea surface temperature rising, in terms of droughts and extreme events, overall seen is negative, especially for areas or countries like India, who are more vulnerable because of their high population density and high hydrometeorological disaster situations. For us, yes, we have to be very, very vigilant.
Any further questions from the audience? They are all frozen, it seems, sir.
Yeah.
So if not, then I would like to request Dr. Devinder to propose a vote of thanks for today's talk.
Thank you, ma'am. Honorable Speaker, distinguished member of the Geological Society of India Delhi chapter, faculty colleagues, and esteemed participants, good evening. On behalf of the Geological Society of India Delhi chapter, I am delighted to propose a vote of thanks for this remarkable online webinar on geological exploration of Amery itself. First, I extend our heartfelt gratitude to Professor Naresh Chandra Pant, visiting honorary scientist at the National Center for Polar and Ocean Research, Goa, for taking time from his busy schedule to share his exceptional insights into one of the world's most challenging geological frontiers. His presentation eloquently demonstrated India's significant contribution to the international polar science and provided us with a fascinating glimpse into the complexities of sub-ice geology and the GeoEAIS program. The expertise and clarity he brought to this discussion have certainly enriched our collective understanding of cryospheric geology. I would also like to sincerely thank Dr. Asima Sakya, Associate Professor at the Department of Geology, University of Delhi, whose meticulous coordination and leadership ensured the smooth conduct of this online event. Her dedication to fostering scientific discourse within our chapter is truly commendable. This webinar is also a testament to the collaborative spirit of the Geological Society of India Delhi chapter, an organization dedicated to advancing geological science and fostering intellectual engagements among its members. On a personal note, I am profoundly grateful to Professor R. Bhaskar, whose constant encouragement, mentorship, and steadfast support have been instrumental in my academic and professional growth. His belief in my abilities and the invaluable opportunities he has provided have shaped my career and enabled me to contribute to the initiative like this. I would also like to acknowledge all the participants who joined us from across the country in this virtual setting, bringing their enthusiasm, questions, and perspectives to enrich our learning experience. The success of an online webinar truly depends on such active and engaged participation. In closing, this webinar exemplifies the power of science communication and collaborative research in addressing critical questions about our planet's geology and climate. Let us continue to support and participate in such knowledge sharing platforms. Thank you all, and I wish this webinar contributes meaningfully to your understanding of polar geology and India's role in advancing earth science globally. Thank you.
Thank you.
Thank you, Pansab, for time, and thank you, Devinder and Ashima, for the
Thank you, sir.
excellent event organized.
Thank you.
Yeah, thank you, thank you. Thank you. Namaskar,
you.
Rasik Saab.
Sir,
Namaskar.
we can
Thank
ask
you.
for
Thank you, everybody.
all participants to turn on their camera and we can take a screenshot.
Yeah, please do it. That's good idea. If they wish to.
You may have to have 2-3 frames.
All participants, you are requested to please turn on your camera so that we can take a photograph. Yes, I'm not able to see all this. Okay, thank you very much.
Thank you. Good night.
Night, sir.
Bye.
All
Good
of you.
night.
Good night.
Thank you.
Thank you.